Today we'll be reflecting points in a coordinate plane. Okay, when we are reflecting points, we first need to understand what reflection means. Okay, reflection is a lot like a mirror in that my hand is a certain distance away from the camera, and then on your side, it looks exactly the same distance. This is a reflection of my hand. Okay, as it moves closer, my hand gets closer. It looks closer, right? And as it gets further, it looks further, okay? The distance is the same both in the picture and in real life, okay? So if I am reflecting a point, we'll say this point, and I want to go across the y-axis, okay, that's my vertical one. If I'm reflecting it, it's 1, 2, 3, 4 spaces away, which means it's going to be 1, 2, 3, 4 spaces away. Well, on my point here, it's going to be +4, 3 to start. And then when it was reflected, it went from +4 on my x-axis to -4 on my x-axis. And it stayed 3 on my y-axis. So when I reflect across my y-axis, my y value stays the same. My x value, it becomes the opposite. Okay, see that? All right, so y, when I reflect across my y stays the same. Okay, we take the opposite of the x. Now, what if I reflected this point across the x-axis? Okay, again, distance needs to stay the same, so it's 3 spaces away. So it needs to be 1, 2, 3 spaces away, and it'll be right here, directly vertical to it. Okay, so my new point here is still 4. Then it becomes -3. So we reflect across the x-axis. Well, my x value stayed the same. And then I took the opposite of my y value. Okay, so uh, whatever axis you are reflecting across, that value stays the same. And then we are taking the opposite of the other value. Okay, so let's think about if I have the point 1, 5. Actually, let's start with -1, 5. Okay, so the point -1, 5. 1, 2, 3, 4. Oh, that's positive. Or 1, 2, 3, 4, 5. -1, +5. Okay, this point here, if I reflect it across the y-axis, that means my y value stays the same, so it's going to be 5. And then I take the opposite of my x value, so it's going to become positive. So I'm going to plot my point at 1, +5, 2, 3, 4, 5, and you can see that that is a reflection of the original point. What about, let's say I'm doing -2, -2, -2, -2. And let's say I reflect that, -2, -2, across the x-axis. Okay, so if I go across my x-axis, that means my x value stays the same, and I take the opposite of the y value. Okay, so I'm going to plot my new point at -2, and it's going to become +2. And you can see that this is a reflection. Okay, it's directly across from. Okay, so now let's take a look at some problems that have fractions or decimals involved. Okay, so our rational numbers. Okay, so write an ordered pair that is a reflection across the x-axis. So again, if we're across the x-axis, that means the x value stays the same. So -5, 2/3, and then we take the opposite of the y value, so that becomes -1/2. Okay, and that's your new point. All right, so across the x-axis, which means this stays the same, and then I take the opposite of my y value. Okay, there's a couple more for you to try. And then we'll take a look here. This says the owners of Polly's Pool Company is pouring concrete for a rectangular pool. He pours the first corner at 6.5, 6.5. So positive, positive. What is the location of the corner that reflects across the y-axis. So it's across the y-axis, which means my y value stays the same, and I take the opposite of my x value. So it becomes negative 6.5, 6.5. Okay. Again, this next one, groundskeeper is preparing a field for a soccer match. He begins by setting the first corner at 12.5, 12.5. What is the location? The corner that reflects 12.5, 12.5 across the y-axis. So again, y-axis stays the same. My x-axis becomes the opposite. So negative 12.5, 12.5. There's two more for you to try like that. Then let's take a look here. This says the point z prime, which just means the reflected point, that little parenthesis, or not parenthesis, that little apostrophe. The little apostrophe there means it's the second one. So it was reflected. Okay. So the point z prime is at negative 5, 3 is the result of reflecting. So the original was 5, positive 3 in the coordinate plane. So look, the 3 stayed the same and we took the opposite of the x. So that means we went across the y-axis. My y stayed the same, so we went across the y-axis. We took the opposite of the x. Okay, this one here. All right, so again, this is the ending point. All right, so we started here. Looks like my y stayed the same, and I took the opposite. So again, across the y-axis. Okay, this one, negative 6, negative 6, my x stayed the same, and we took the opposite of the y. So my x-axis was the one that was reflected. Okay, try number 16 on your own.